Hey everybody, I'm David Justice, and I am here to talk to you today about building applications on Azure and leveling up your DevOps maturity. So a while back, started this post on DevOps maturity and just using open source tooling on Azure to deploy out Azure infrastructure and applications. And today we're going to talk about building an application in Azure using Rails, Ember, CosmosDB, and some good patterns for security as well as leveling up your DevOps. So without further ado, let's actually look at the app real quick. So I'm going to start it up. I have locally running. I have the app basically set up locally here. And we're going to run Rails and serve Ember from the app. All right, cool. So we have localhost running. I'm going to pull up Chrome, and so cool. Here we have our Ember app running. We can see we have like a to-do list, kind of your prototypical, something that's relatively close to a real-world example. So we have our post here. We can see we can turn them on, turn them off. I'm going to go back. I can go create a new one. All right, cool. I can go and add new items. I don't know, something. Yay. Delete them, all that stuff. Yay. So as you can see, we're going through, and it's running locally against Mongo. So I have a Mongo instance running locally, and it's finding the to-do items, deleting them, inserting them, doing all the normal CRUD operations that we'd expect. So I'm going to delete this guy right here. You can see it. Hopefully you can see. So it started the delete, and it went through. Okay, so let's turn this off. And I'm going to turn off Ember, and let's look at code for a second. So here we are in VS Code, and this is the root of level 1. You can actually go out and grab this code yourself and start playing with it if you wanted to. This blog, hopefully you found this via the blog post, but you can go hop out and hit up level 1 on GitHub under defined. So here you can see there's scripts, there's API Ruby, and then there's a to-do Ember in here. That's kind of the structure of it. It doesn't have to be that structure, but it just for ease of deployment here. The major one that we want to look at is provisioning, and then our cloud init template. So just for time's sake, I'm going to go through and I'm going to kick off provisioning right now with Azure, with Bash. So we're in API Ruby. I'm going to actually go up to the root, and I'm going to say script provision. And so this is going to kick off our provisioning script. So this is building up a bunch of infrastructure in Azure, and I want to get it kicked off while I explain exactly what we're building. So as you can see, that's going on right now. So let's talk a bit. So here's the infrastructure that we're looking to build. We want to build up, we want to have a VM scale set within a VNet fronted by a load balancer. And the VM scale set is going to have multiple VM instances, and it'll be able to scale up and down as we have load. Each one of those instances will have Nginx and Rails with Puma running. And then each one will actually have Azure CLI loaded on it as well. And with Azure CLI, we are going to actually provision a certificate from Key Vault here over onto these machines, provisioned via the Azure Provisioner. And then we're also going to allow these machines and the identity that these machines are running on to access secrets within Key Vault. So this is going to give us a really nice ability to kick off Azure CLI activities from within the VMs. So that means we can go and grab our connection strings. We can get secrets that we need to communicate to different services. These things are greatly important when you don't want to bake secrets into your application. And then each of these applications are going to speak to CosmosDB through its MongoDB endpoint. This is going to give us a really nice integration with Rails through Mongoid using a schemaless database, and CosmosDB is really cool. If you haven't had a chance, take a sec and go look at it. It's a globally distributed database. If you don't like owning a Mongo cluster, think about moving to CosmosDB. SLAs around latency, throughput, availability, and its consistency as well. It's fantastic. And then clearly, you can't really have a website or a legit website unless you're actually fronting it with CDN. So we're going to use Azure CDN, and we'll use the default of Akamai for the edge nodes. So basically, we're going to have level 1 Azure Edge. Level 1 is kind of in quotes here. It may be kind of hard to read, probably easier on the blog post. But this is just a dynamic value generated by the script, so that not everybody's script steps all over everybody else's scripts. Because it's a global DNS value, each script would have to be different, so we just kind of dynamically generate it. And then again, this CDN instance ends up fronting this DNS entry for the public IP address for the load balancer for the VM scale set. Okay. This public IP exposes port 80 and then has mappings from the front end address, front end port of 50,001 through 3, or it depends on how it was built, but this is probably going to be your port range, mapping back to SSH on each of the instances. This will grow and shrink based on scaling up or scaling down the scale set. Let's see. What else? Yeah, I think that's about it. So let's actually go through the script itself, and while it's provisioning, we'll take a look and see what we're doing. Okay, so first, actually, let's go through the provisioning. So as you see, line 4 here, we just want to bail if we have any errors or anything like that as quickly as possible. Just drop out. If I reach any ambiguous areas, I don't want to continue. And then just set up a bunch of variables so that we can make this as concise as possible in the script. And the new name variable here is actually nice, but you wouldn't need it if you were writing a script for your own infrastructure. It's only really useful for like examples like this where that new name is going to be used in global DNS entries. So your script might stomp on somebody else's, but in all likelihood, you're going to have your own DNS entry, and that DNS entry isn't going to change. So this is just kind of more for a public demo. So what we're going to do first is we're going to check if the CLI is logged in. If we can do an account list, then we're going to say we're logged in. And then we're going to come through and we're going to actually create a group if the group doesn't exist. Now, you'll see this pattern a lot in this code. We'll run the if statement to check if something exists rather than actually trying to run another create. Now, most Azure operations are just idempotent, so you could call create with the same parameters and expect the same result over and over again. But it actually takes a little bit longer to do that. So the script runs much faster if we just check to see if something exists, and if it doesn't exist, then go on our merry way. Next, we're going to create the key vault instance, and as you can see, we're using that new name here. The new name ends up being a DNS entry. So Everywhere you're going to see -G with the group ID, so that's your Azure Resource Group, and then -N with the name of the resource. And we're going to enable deployment here. So what that means is we're going to enable this key vault's usage for deployment, for provisioning VMs, so that that key vault can have certificates used from it on the VMs. So that's going to be really powerful, and I'll talk about that in just a little bit more. So we're going to go and see if we have a certificate in Vault with this given name. And if we don't, we're going to create it. And we're also going to create our secret key base, our Rails secret key base here with this value, and dump it into Vault. When we're doing the AZ create certificate here, we're actually creating a self-signed certificate in Vault. And we're asking Vault to create it for us, rather than us running the key creation locally and having our public and private bits locally. These never have to touch our development machines. They're actually just only in Vault, only in our production environment. So this is really great. You don't want private bits in the hands of people. Anytime you can keep like secrets and stuff like that away from humans, the better off you are. This secret, on the other hand, you could imagine running like Rails secret and piping it into Vault through the CLI. You could do something like that. Just for laziness, I put it in here. Obviously, you would never do that in real life. So what do we do next? All right, we're going to go build CosmosDB if we don't have one that exists right now. And we're specifically going to use the kind Mongo here. So CosmosDB is a multi-model database. So it supports graph database, it supports DocumentDB, it supports MongoDB, and it's really awesome. Give it a shot. I think you'll like it, particularly for like Mongo support. For folks that know about running Mongo clusters, I hope you haven't run into horrible issues, but it's never been a joy in my life. So let's see here. And then we're going to come in to 56 or 58. We're going to actually create a service principal. So the service principal creates the identity for us in Active Directory. And this identity, we can assign roles and rights to that identity so that we can limit or expand the amount of access that this login or this identity has in our Azure subscription. This is super useful for automation. So if we want to have something that is easily automated, does not have multi-factor auth, like most user accounts, almost all user accounts in Azure should have multi-factor auth. But we can't have multi-factor auth for automated processes. So this allows us to create an identity for an automated process or something that we would want running without human interaction. So we're going to actually create an identity here that we're going to put onto each virtual machine so that we can run as that identity for Azure CLI so that we can access secrets and different Azure infrastructure information. Really helpful for deployment and running applications. So you can just drop an application somewhere and it picks up the identity of where it's running. This is kind of the way you want it to run. So then after that, we're gonna remove, if we already have it, our PEM file here. That's the public side of the cert, and we're going to be downloading that right here. So the cert that we created in Key Vault, we're going to ask it for the public side, and we're going to say, okay, cool, we get the public side, and then we're going to create this service principal. Oh, I'm sorry. This actually just deletes it if it exists. I misread that. Here is where we create it. So AZ80 SP create for RBAC actually creates a service principal and gives it default role-based authorization to Azure. So with the public key of our certificate. So basically, we now have set up that certificate in Key Vault and have a public key associated to it, associated to an identity that we can use in Azure to authenticate. So we're next going to give Key Vault, or give that service principal we're going to give the service principal access to Key Vault so that it can list and get secrets. Not list, actually, just get. So it has to know the ID of the secret that it wants, and then it can pull down the information. This is really useful because we're going to use it to pull down the secret key base that we just set up here. Okay, so next we get really into the heart of this build out. And this is where we're going to build out the VM scale set and do our secrets manipulation so that we can bootstrap our VMs with Azure CLI. So here's the secret. We're going to ask Key Vault, give me a list of your secrets with the cert name that I want, and give me one that's enabled. And so the latest one that's enabled. Key Vault certs have multiple versions, so you can roll a cert forward, and it'll be the next enabled version. This is really useful for rolling certs. You still keep the same other cert. So say you're doing key encryption or something like that. You can go back and find the older cert that you used to do key encryption and still be able to use it. But still be able to grab the latest one and then use that one instead. Let's see. So next we're going to go through and we're going to format secrets. So the formatting of secrets, basically this puts it into the format that the VM accepts. So basically it's like the source vault and the ID of where the secret is. And then we're going to get the tenant ID and fingerprint, and then we're going to dump the tenant ID and fingerprint into our cloud init or cloud config template. What does this template look like? So this template is right here, and it has these variables that I threw in here that we're going to replace. So it has a fingerprint. So the Azure Provisioner, when we give it a secret and we ask it to put that secret onto a machine, so a secret is a certificate, synonymous with a certificate in Azure, it's going to drop it in var lib wa agent and then the fingerprint of that the fingerprint of that cert. And likewise, it's going to do that with the private side. So you got the public and private side. They're both in PEM format. So we're just going to cap those together and drop them into the home directory of the user that we're creating for the VM. We're just going to own that. And then finally, we're going to go through here and we're going to log in with Azure CLI with the tenant and username of the service principal using the newly combined certificate that we have. This is actually going to bootstrap Azure CLI, so it's automatically logged in so that we don't have to call login from any of our deployment scripts after this. It just works. And it keeps track of where this certificate is, so it'll keep that account live and you'll be able to keep using it. If you're not familiar with Cloud Init templates or Cloud Init, this is just a really nice way for us to declare all the things that we want on that machine. It's kind of like the personality of the machine. So we get these clean boxes, the clean cloud image, and then we push our Cloud Init onto it and it executes, and then boom, at the end of it we have a customized machine. And I'll show you where that gets pushed. So we run sed, just go and dump that stuff out. And then we have our VMSS create, takes our group name, the VMSS name, our instance count, deployment user, our image, and our secrets that we've set up here, our custom data, and the custom data is your Cloud Init. And then we're going to go through and we have a public IP address, and we're going to give that our new name, our randomized DNS name, and we're going to give it the name for the public IP address. So this allows us to call out to the public IP in the future, go fetch it with Azure CLI, so we know what it's named and we can control that name. And likewise, we're going to control the load balancer's name too. Next, since that just created our VMs and everything is up and great, we're going to go through and we're going to actually open up port 80 on the load balancer and create a health probe. So this probe is going to look for failures on port 80 over HTTP at the root. So if our site's not responding, it's going to take the app out of the load balancer. We don't want it to be out there servicing requests if it's a dead app or something. Finally, we're going to go through and we're going to set up a load balancer rule specifying the probe, and then we're going to set up that rule for port 80, mapping it to the backend pool on port 80. So routing from that front end port here to Nginx on the back end on port 80. All right, so after we have all that set up, then we can come down to 90 through 99 here, and we're going to create a Azure CDN profile and endpoint. A profile describes, who owns your edge nodes, whether it's Verizon or whether it's Akamai. And then the endpoint specifies the profile and the origin. So it brings the profile and the origin together. So your profile, your endpoint has a edge URI. So it goes like your name.azureedge.net, and it points back to the origin. And the origin is whatever site its content you would like to front. So we're going to serve up our CSS and JavaScript over the CDN. So that's why we want to front it. Okay, so that is all of our provisioning. All right, cool. We have all the information we need here. Let's just log in and see if we have the things we need. Ember. And there we go, AZ group list. Awesome, so we have our groups, we have AZ already logged in. Now that we have everything provisioned, we have access to AZ, we have all the things laid out. Why don't we go in and deploy our app? So we're going to go into API Ruby. And from in here, we're going to run bundle, execute, cap production, deploy, initial. All right. Cool. So now we're deploying out our Rails application onto our infrastructure. So what just happened here? If we hop into API Ruby, we're using Capistrano. Capistrano, if you aren't familiar with it, look it up. It's a pretty common Rails deployment tool. But what is our this is our deploy RB, and our deploy RB is kind of your basic your Rails Capistrano deployment script. So here we're shelling out to get our list of VMSS connections. So this is kind of cool. We can hop over and give this a run here. I'm using source code version or source version of Azure CLI. Off a master because I was doing some work in it. So as you can see, we're using, we have list instance count, here's our group, and here's the name of the VMSS that you're going to be spinning up, and here are the IP addresses. Here's the front end IP to the SSH port. So we see that's just what we need for the app here to describe all the different instances that we have. And this will dynamically change as we add more or less instances. It's kind of nice. And then finally, we end up going through here, and it's going to deploy out everything, make sure that you have your latest out there. On the initial, we're going to go and make sure Nginx has our active site set up. But the cool part here is building the Ember assets. So we're going to ask for the API host to find out where a Rails API is. And that's going to be the public, fully qualified domain name for our service. It could be a custom domain name for you or some other domain name if you wanted to. But this is just where our Rails app is going to respond to. And then we're going to ask, we're going to actually replace the config environment for Ember. So what that looks like is our Ember config environment has a setting here that we're just going to drop in the API host. So it'll pick up the API host. We've already set up the Ember build so that the Ember build.json here is going to prepend our CDN host. It's going to take the environment variable and prepend that CDN host. And the way it does that is from the deploy script here. It's going to pick up the CDN host by running azcdn endpoint list, get the for the profile, and find the first one and get the host name. And then it's going to execute an Ember build silent in production. So that'll give us our endpoint, and the only way we could run this, and this task actually runs out on the remote server, and the only way we'd be able to run that is if we had a pre-authenticated version of Azure CLI out there. So that's what runs, and let's see how we're doing here. Okay, so it looks like we have everything we need here, and it's running. So let's find out what our endpoint is. Let's hop back here and just say, I'm just going to steal this. This should give us our fully qualified domain name. All right, so here we are, and I'm going to go drop that into a browser and cross our fingers. Hopefully this works. Yay! All right, so let's look at the inspect here. And what failed to load? Oh, the fave icon. Yeah, I did put one in there. So let's take a look at our network stack here. All right, so here we go. Grab 200. So we have our vendorized assets, and they're coming from Azure Edge. So it looks like we're getting them from the CDN, and we're getting the other content from the API. And our API is responding to a to-do lists, getting a 304 unmodified, and what's the response look like? No data. All right, so how about we get some data in there? A new list. This is my new list in Azure. I'm going to save that. Super. We'll hop in here. I have a new to-do. Pick up food at store. Work out. I don't know. Check. Delete. Super. Okay. So how about we go back to root here and just see what root says now. So we see our new list. Yay. We see XHR, and here's our data. So now these are coming back from our deployed Azure Cosmos. We've deployed out our Rails app. Everything's running. Bob's your uncle. So I think that pretty much covers it. The main things to take away here are that we're building infrastructure in a way that provides us an identity to fetch secrets, and that we don't have to bake secrets into our source code. It's also a great inner dev loop. We can build locally using Mongo and use our regular tools that we use locally, and then just fluently move that up to the cloud. and just change out some connection strings, and everything just works. I hope, if anything, you walk away from that wanting to try CosmosDB or thinking about hosting your apps out here. We'll come back in the next one and try to up our level a little bit more, move into more config management tooling, and possibly in the future start looking at multiple regions and monitoring. So we've only covered like a really tight topic area, and almost only like deployments and deployment scripting, and that's such a small part of like running an application that it's silly. So for us to actually really level up, we really need to go through like infrastructure as code, monitoring, running of like apps over long terms, as well as like really start getting into immutable infrastructure, and the benefits that we get there. And not to forget about continuous delivery as well, delivering out our value quickly. Yeah, if you have any questions, please hit me up on Twitter, David Justice, or hit me up via email, david.justice@microsoft.com. Thanks.